transformations. Your graphs do need to be drawn by hand, but do use GeoGebra to check your work, right? You should know if you did these right before you hand them in. So we'll do one together, everything by hand, and then we'll check it in GeoGebra. So this is my transformed function that I'm trying to graph. X plus 3 cubed minus 1. So what's the parent function? What function can I start with and then say, like, okay, I'm going to start with blah, and then this and this happens? X cubed. Yeah, you're going to start with f of x equals x cubed. Okay. And then before I move on to what comes next, I'm just going to jot down, what does that plus 3 inside the parentheses tell me to do? Left 3. So that says left 3. And what does the minus 1 tell me to do? Down 1. So I'm just writing those down for myself. Now my parent function, I just want to make a table of values, just so to graph the parent without having to even think about transformations yet. So I've given you some x's, you just calculate the y's by plugging into x cubed. So negative 2 cubed is negative 8, negative 1 cubed is negative 1, 0 cubed is 0, 1 cubed is 1, and 2 cubed is 8. Now in the transformed function, I've given you the x values, but you'll see that the points we're going to create come from the parent function points, right? So if I look at the point negative 2, negative 8, right? And I move left 3 and down 1. To move left 3, I'm going to land at negative 5, down 1, negative 9. Right? So I gave you the negative 5 here. You just had to know that that goes to negative 9. And then my next point, negative 1, I'm going to move it left 3 and down 1. So subtract 3 from the negative 1 and I get negative 4. Subtract 1 from negative 1 and I get negative 2. So negative 4, negative 2. My point 0, 0 from the parent. Left 3, down 1 lands at negative 3, negative 1. So I gave you the negative 3, you need the negative 1. So these are points on the parent. These are points on G. Right? So that's my parent F. These are corresponding points on G after I've performed the transformation. So 1, 1. Go left 3, down 1, and I land at negative 2, 0. Gave you the negative 2, just put in the 0. And then if I go left 3, I get negative 1. Down 1, I get 7. And then I'm supposed to plot all of it, both F and G. All right, so see, I'll do F in black. Negative 2, negative 8. Negative 1, negative 1. 0, 0. 1, 1, 2, 8. So this is the graph of f of x equals x cubed. And now I'm going to plot the points on G, the corresponding points on G. I have negative 5, negative 9, negative 4, negative 2, negative 3, negative 1, negative 2, 0, and negative 1, 7. Connect those. And that's my transformed function G. So you can see I moved it left 3, down 1, the whole thing. Now there's just a couple of questions about what we did. So I want to do the domain and range of the parent, that's F. So the domain and range of x cubed is negative infinity to infinity for both of them. So it's going to be the same for G, because if you go negative infinity to infinity, even if you move left 3, it's still negative infinity to infinity. And even though the range was all real numbers, so even if you shift down 1, it still reaches from negative infinity to infinity. All right, using complete sentences, described the exact transformations applied. Be sure to include language, so they're just saying say it right, right? So we shifted f was shifted 3 units left and 1 unit down. So note that the points you plotted for the transformed function correspond to the points you plotted for the parent. So that's what I was showing you with the arrows here. So they correspond to the transformation. So that's the first one. But then after this one, I didn't give you the x values for the transformed function, but I do want them to be corresponding to the points in the parent function table. All right, I think that's good to get you started. That was sort of the easiest one, but at least you get the idea of what you're supposed to be doing.